Hello, this is a video in which we are going to deal with how to maximize profits and the different models of competition. So perfect competition, monopoly, and the many different versions of oligopoly we could be having, right? To make things very simple, we're going to assume we have a linear demand function where the price equals to A minus BQ, and we are also going to assume that there are no costs, not because costs are not important, but because we don't want to get the cost into the messy calculations in order to understand the main lessons we are going to learn here. Okay, so if we start with a linear demand function, price equals A minus BQ, we can draw it in our main graph, in which here we have the price and here we have the quantity. If price equals to A minus BQ, when Q is 0, the price is going to be equal to A. And when the price is exactly 0, the quantity is going to be A divided by B. What we are going to see is in which point of this demand function perfect competition will be, which combination of price and quantity, in which point it will be the monopoly, and in which point it will be the oligopoly, right? We're also going to use the best response function when we talk about duopoly with two companies, firm 1 and firm number 2. So let's start with the simplest model. Let's start with perfect competition. As a consequence of maximizing profits under perfect competition, what is going to be the price and what is going to be the quantity? Well, under perfect competition, we know that the price is going to be equal to the marginal cost. If the cost is 0, obviously the marginal cost is also 0. So the price is going to be equal to marginal cost, price equals marginal cost, so the price is going to be equal to 0. Given that the price is 0, then we substitute 0 in the demand function and we see that the quantity is going to be A divided by B. So under perfect competition, we'll be at a point down here where the price is exactly 0, the quantity is A divided by B. This is what happens under perfect competition. Okay? Now, let's see what would happen, model number 2. What would happen under a monopoly? Well, under a monopoly, we know that the price is going to be equal to the marginal revenue. What is the marginal revenue? The derivative of the revenue. What is the revenue? Price times quantity. So if revenue is price times quantity, the price is A minus BQ times quantity. So the marginal revenue is going to be the derivative of revenue with respect to Q, meaning A minus 2BQ. Given that marginal revenue equals marginal cost when we are under a monopoly and the marginal cost is 0, this is going to be 0, and therefore A minus 2BQ equals 0. So Q equals A divided by 2B. And when Q is equal to A divided by 2B, of course the price equals A divided. So the quantity, equals A divided by 2. So we know that under a monopoly, this would be the monopoly. What a monopoly does is it reduces quantity in order to keep prices high. How high? Highest price, the profit maximizing price, if you don't have any competition, is A divided by 2, and the quantity is A divided by 2B. Okay? Let's move into oligopoly. So let's assume now we have two companies, company 1 and company 2, both deciding quantities at the same time, simultaneously. So that's what we call the Cournot model. Okay? Under the Cournot model, we need to write the profit maximization problem of each of the firms, find the best response function, and now make the best response function mutually compatible. So let's start with the profits of firm number 1, who's maximizing their own profits, deciding Q1. What are the profits of firm number 1? The price, which is A minus B, but now the quantity is going to be the quantity that firm number 1 produces plus the quantity that firm number 2 produces. A minus B multiplied by Q1 plus Q2, that's the price, times Q1. This is the revenue minus the cost. Again, the cost is 0. So the best response function of firm number 1 will be the derivative of all this with respect to Q1, which is going to be the derivative of profits of firm 1 with respect to Q1 equal to A times Q1, that's A, minus BQ1 times Q1, that's the derivative is going to be minus 2B Q1, and finally minus B, and the Q2, because we don't know how much the other firm is producing, for us it's a constant. So minus B Q2 multiplied by Q1, that's going to be minus B Q2. And of course, it's the best response, so this equals to 0. So from here, we get that the best response of firm number 1 is Q1 equals A minus B Q2 divided by 2B. A minus B Q2 divided by 2B. And of course, the best response function, so we can draw that actually. We can draw here, if this is Q2 and this is Q1, if Q2 were 0, Q1 would become A divided by 2B. A divided by 2B. And if Q1 was 0, this goes to the other side, so Q2 will be equal to A divided by B. This is the best response function. Best response of firm number 1. Whatever they expect Q2 to be, this is the way they will respond. If they expect the other firm to produce very little, they produce all this much. If they expect the other firm to produce quite a lot, it may be up to a point where they produce 0 in order for the price not to go down too much. Now, this is the best response function of firm number 1. Of course, because everything is symmetric, the best response function of firm number 2 is analogous, A minus BQ1 divided by 2B, right? So we can draw that in a graph in which we would have basically something like this, where this is going to be A divided by 2B, and what is Q2 if Q2 is 0, Q1 is going to be A divided by B. So this point is A divided by B. And of course, this is the best response function for number 2. So the important thing is to find what is the equilibrium. The equilibrium is going to be the point in which everybody is doing the best response to what they think the others are doing. So when the two best response functions are compatible, what does it mean? It means that the way to solve this system of two equations with two unknowns, Q1 and Q2, is to substitute one in the other. So Q1 will equal A minus B, that multiplies, and where it says Q2, we can write A minus B Q1 divided by 2B, right? And everything divided by 2B. So from here, we have that 2B Q1 equals A. The B with the B, they cancel out, so A minus A divided by 2, minus times minus is plus, B divided by 2, Q1, and that's it. So from here, we take the B's, we put them together, so the minimum common multiple is 2, so this is going to be 4B Q1 minus B Q1, everything equal to A divided by 2. We can take the 2's out, and we basically get what we want, which is Q1 equals A divided by 3B, which, because everything is symmetric, is the same as Q2, right? So in total, the total quantity is going to be 2A divided by 3B, which is something that is bigger than A divided by 2B, but smaller than A divided by B. So 2A divided by 3B may be something around here, 2A divided by 3B. And we take that quantity all the way here, and we find that if Q equals 2A divided by 3B, the price equals A minus B multiplied by 2A divided by 3B. The B's cancel out, and we have A minus 2/3 of A. So that's 1/3 of A, or the same as A divided by 3. So this is what happens under Cournot. Okay, we see that an oligopolistic situation is something in between perfect competition and monopoly. Now, let's see a few things here. For example, let's see if it were possible for these companies to actually agree. So let's see what would happen under collusion. Okay, collusion. What is the best possible agreement these companies could reach? Well, whatever it maximizes total profits, and then each firm will be selling half of those total profits. Well, the price and the quantity that maximize total profits is actually the monopoly quantity. So the agreement they would like to reach is to say, you know what, let's produce the same quantity as a monopoly, and each of us produces half of the monopoly quantity. So that means in total production is A divided by 2B, and each firm should be producing, Q1 should be equal to Q2, each firm should be producing half of the monopoly quantity, so half of A divided by 2B, so A divided by 4B, right? if they actually make that agreement, the price would be the same as a monopoly. The price would be A divided by 2. Now, is this actually going to happen? No, it's not. Why? Because let's see if when firm number 1 expects that firm number 2 is going to fulfill the agreement, whether they are in the best response function. So if I think firm number 2 is going to produce A divided by 4B, so something around here, A divided by 4B, what should firm number 1, whose best response function is this line, should do? Well, whatever we find here. They should produce, actually, they should not produce A divided by 4B. They should produce more. How much? Well, let's go to the best response function and say Q1 when Q2 is A divided by 4B is going to be Q1 equals A minus B multiplied by Q2. But what is Q2? Well, what you expect Q2 to be A divided by 4B. Everything divided by 2B. So from here, the B's cancel out, and you have that 2B Q1 equals A minus A divided by 4, which is 3/4 of A, right? So what should you be producing? So A minus, yes, this is 4, 3/4 of A. Yes, this is fine. So Q1 should be equal to 3 divided by 8, A divided by B. 3/4 of A divided by B, which is actually more than what they promised they would be doing. So they will produce more, 3/8 divided by 3/8 A divided by B. So this is 3/8 A divided by B, right? So notice that this is not in the best response function of firm number 1. For number 2, actually, firm number 2, because everything is analogous, firm number 2 would also produce 3 divided by A times A divided by B. So in total, the total quantity would be Q1 plus Q2 would be 2 times 3/8 AB. So this is the same as 6 divided by 8, which is the same as 3 divided by 4, A divided by B. So what's going on? Well, the total quantity is 3/4 of A divided by B, which is going to be something around here. 3A divided by 4B. And as a consequence, the price, when the total quantity is 3/4 of A divided by B, the price is going to be even lower. So the price is going to be equal to A minus B multiplied by 3/4 of A divided by B. Again, as always, the B's cancel out, and we have that the price equals 1/4. Okay, 1/4 of A. So this point here is 1/4 of A. So what we are learning in this lesson is that companies try to produce a lot. They try to agree on reducing quantity to keep prices high and benefits to be and profits to be high. But actually, because they don't trust each other, each of them ends up producing 3/8 of A divided by B. So they produce a little bit extra, thinking that the other is going to satisfy the agreement. Because they both produce 3/8 of A divided by B, in total they produce 3/4 of A divided by B, and as a consequence the price is much smaller. So when there is collusion but they don't satisfy the agreement, they end up in a worse situation. Both companies end up in a worse situation than if they had not agreed anything in the first place and they were just competing in quantities. Okay? So this is the result under collusion. Let me write it here. Let me delete all this, such as we just keep on the whiteboard the result, which is quantity 1 equals quantity 2, which equals 3/8 of A divided by B, and the price equals A divided by 4. Okay? Now, what else we could do? Well, we could also look at sequential competition. Sequential. Okay? What would be the result of sequential competition? Well, in this case, we would have firm number 1 moving first, firm number 2 moving second. Now, because firm number 2 moves second, it seems like they have the advantage of observing what firm number 1 has decided. However, that's not the case. Why? Because, it's good to know what the other has decided, but to be second in that sense, but you are only adapting to whatever firm number one has decided. So actually there is what we call first mover advantage. It's best to be first and then decide your Q1 taking into account that Q2 will have to adapt to what you have to do, to what you have decided to do. Meaning you may prefer to produce a little bit more, such as at the end, firm number 2 that comes second will just produce just a very tiny bit. Why? Because they will be very afraid that if both firm number 1 produces a lot and firm number 2 produces a lot, the prices are going to go down and profits are going to be very low, right? So under sequential competition, what we have is that firm number 2 still is going to behave as in the best response function. They will adapt not to what they expect firm number 1 does, but actually to what firm number 1 does, because they observe what firm number 1 has already done. But the issue is that in the problem of firm number 1, they will be incorporating how firm number 2 is going to adapt. So now, maximizing P1 with respect to Q1 is going to be equal to A minus B, Q1 plus Q2. But what is Q2 going to be? The best response function. So it's going to be A minus B, Q1 divided by 2B. Okay? That's going to be the price times the quantity. So the first order condition here, or the derivative of this with respect to Q1, derivative of pi 1 with respect to Q1, now equals 0 is going to be A times Q1, again, this is going to be A, minus B Q1, Q1, so that's minus 2B Q1. All this part is exactly the same. And now we have to be careful. Minus with plus is minus, and then B with B, they cancel out, and then we have A divided by 2 times Q1. So the derivative is going to be A divided by 2, if I'm not wrong, with a minus sign. Fine. And now, the B with the B, they cancel out, the minus with the minus is a plus, right? And then we have the B's cancel out, we still have one B, right? So there's going to be a B. We also have Q1 times Q1, which is Q1 squared, so the derivative is going to be 2B Q1, right? So all this equal to 0. So A minus A half, this is going to be A divided by 2, minus 2B plus 2B Q1. Seems like there's something wrong. Yes, what is wrong? I'm missing these 2 here. There was a 2 dividing here. So this is 2 divided by 2. Right? Let me make sure this goes out. This is half, but this is B Q1 squared, so the 2 with the 2, they cancel out. So what we have is 8 divided by half minus 2B Q1 plus B Q1. So minus B Q1 equals 0, and therefore Q1 equals A divided by 2B. Notice that the first mover, the first company, is actually producing the monopoly quantity, exactly the monopoly quantity. Is that the total production there's going to be in this model? No. Why? Because firm number 2 will adapt and they will produce something. They will be in their best response function. So when Q1 equals to A divided by 2B, we substitute there and we find that Q2 equals A minus B, where Q1 is A divided by 2B, right? Everything divided by 2B. So again, the B's cancel out like always, and we have that 2B Q2 equals A divided by half. So we have that Q2 equals A divided by 4B, right? And therefore, the total quantity is Q1 plus Q2, which is A divided by 2B plus A divided by 4B. So in total, this is going to be 3A divided by 4B. So in total, the quantity now this is interesting. The quantity when they are behaving, there's sequentiality. There's a first mover and a second mover. The total quantity is the same as if they had agreed on something and they didn't fulfill it. So we already know that the price is going to be equal to A divided by 4. But now the profits are going to be different. Why? Because yes, the price is A divided by 4, but firm number 1 is producing the monopoly quantity, and firm number 2 is just producing half of the monopoly quantity. So the profits of firm 1 are going to be higher than the profits of firm 2. Okay? Good. Now, what else could we do in this model? Well, we could do things very, very simple. One thing we could do is think about what would happen if the competition was in prices and instead of in quantities. Well, if it was in prices, it will be very simple, because in the competition in prices when the marginal costs are equal, just tells you that the best response is always to undercut the price of your rival. Why? Because if you charge a higher price, you're going to sell nothing. If you charge the same price, you're going to sell half of the market. So the best response is always to undercut the price of your rival and always sell the whole market. The volume effect is bigger than the price effect. But of course, each company is going to undercut each other until when? Until the marginal cost. Given that the marginal costs here are equal, both firms are going to sell at a price equal to marginal cost. But that marginal cost in this exercise is 0. So competition under Beltran model, which is competition in prices, right, is going to tell you that the price equals 0, and because the price equals 0, we are also going to be at this point. Price equals 0, the total quantity is going to be A divided by B, but each firm is going to produce half that quantity. So Q1 equals Q2 is going to be A divided by 2B. Here we will be also here under Beltran. Okay? But each firm producing half. Now, with respect to consumer surplus and producer surplus, you can do the calculations. Remember that the consumer surplus will be always the area below the demand function up to the price. So when the price is 0, right, everything will be consumer surplus, and the higher the price, the lower the consumer surplus. The lowest consumer surplus would be at the monopoly situation, and then the more competition there is, the closer we will be to perfect competition, right? What other models I did not discuss? Well, I did not discuss, for example, a monopoly who could price discriminate. A monopoly who could price discriminate, actually what they would be doing is they would be producing as long as people are willing to pay more for the product than the marginal cost. Given that the marginal cost equals 0, they are going to be selling the whole demand function. So a monopoly that is price discriminating is going to also produce the quantity A divided by B, the whole market. But they are going to be infinite prices, as many prices as there are in the demand function. Okay? That's under perfect price discrimination. If there were two different demand functions, then we should not be operating with this graph. We would have to draw two different demand functions, and then we would say, what if you are doing third-degree price discrimination? So what you would do is you would behave as a monopoly in the market with demand 1 and in the market with demand 2, and you would do the same monopoly calculations in each of the markets, and you will see that in one market you would charge one price, in the other market you would charge another price, depending on which of the two markets has the lowest elasticity of the demand. You would charge a higher price in the market with lower demand elasticity. Okay, so I think this nicely summarizes most of the calculations we have seen in the course in a very, very simple example where they are in the course, in a very, very simple example in which the cost is 0, right? Just not to complicate the graph, and in which the demand is linear and it's just a number A minus B, which is another number multiplied by Q. Remember all we have to do. Under perfect competition, price equals marginal cost. Under monopoly, marginal revenue equals marginal cost. Under oligopoly, we have to be careful. If it's simultaneous competition in quantities, we write the profit problem of firm number 1 and of firm number 2, depending on what they decide, which is Q1. We find the best response functions and we make them mutually compatible. And we find what the production is. Under collusion, they would agree on producing the monopoly quantity and each of them producing half of the monopoly quantity. But we show that under those conditions, if I expect the other company to produce half of the monopoly quantity, I want to betray them and I will produce a little bit more. And as a consequence of that, both firms will produce a little bit more and the price will be lower than if actually even lower than could not, than if we had not agreed on anything in the first place. And the sequential equilibrium, again, we write the same problem of firm number one, who is the one that decides first. Remember, when there's sequentiality, we start from the very end with the second firm, and we incorporate the best response of the second firm into the problem of the first firm. So we incorporate the best response function of firm number two into the problem of firm number one. We calculate what firm number one produces, which actually in this case is the monopoly quantity, and as a consequence, the second firm adapts to that. So we substitute the monopoly quantity there, and we see how much the second firm produces. And well, we get actually that in total they are producing the quantity 3 divided by 4b, so the price is the same as if they were breaking the agreement. Competition in prices with the same marginal cost, we know price is equal to marginal cost, so the total quantity is the same quantity as under perfect competition. If the marginal costs were different, remember that you would reach a point in which the price equals to the marginal cost of the firm that has larger marginal cost, but there is a monopoly charging at a price just below the marginal cost of the other company, right? And I think basically that's the summary of everything. We don't have competition in location here because the main decision variables are price and quantity, and of course, what else do we don't have? We don't have price discrimination, but we could look at price discrimination of a monopoly who will be selling the same number of units as under perfect competition, but of course with price discrimination there will be infinite prices. So this price, as many prices as they are, and they will be capturing the whole consumer surplus. Everything will be producer surplus. So please watch this video kindly. Take it easy and pause it as much as you can. I hope you can see all the calculations here. In any case, I'm going to take a side so you can pause it and use it to make sure that your calculations are correct. And if you have any questions, please feel free to email me at pedro.rey@esade.edu. Okay? Thank you very much. Good luck.